Alright, this is your 3.2 notes. 3.1 is just like a review and a preview section. 3.2 is the actual first new section of chapter 3. So in this chapter, we're studying measures of center, the middle of a data set. Alright, and the 4 M's are the most common measures. Alright, mean, median, mode, mid-range. So we've seen mean already. It's just another name for the average, the arithmetic average. Add up the numbers, divide by how many you have. The median is the middle number in a data set, or the average of the two middlemost numbers in the data set. So if you have an odd number of data, there is a single number in the middle, so that would be the median. But if you have an even number of data, then you have to average the two numbers in the middle. Now this data, when you do this, your data has to be sorted, meaning ordered from least to greatest. So when you do the median, you do want to have to make sure your data is sorted, smallest to largest, largest to smallest. Alright, then the mode is the most frequent measurement in a data set. It's the number or the value that occurs the most when you do your measurements. And then your mid-range is the average of the lowest value in your data set and the largest value in the data set. Okay, it's literally the middle of the range. Alright, so let's look at a data set and we'll find these 4 values. So here's 14 different values, and we want to find the mean, the median, the mode, the mid-range. Alright, now I'm going to get out my calculator and show you how to do the first 2 on your calculator. Alright, just like before, to enter your data, you go into your stat menu, press enter for the stat editor, and you just start putting in your numbers. 150, 141. Alright, now I got all my data in, so I'm going to press stat. Alright, and then over here one space is calculate, and we're going to calculate the one variable statistics. So the one variable stats, you hit enter. Now you can hit second L1, second L2, second L3 to tell it which list your data is in, but if your data is in list 1, you just hit enter there. Alright, so the sample mean, according to this, the mean of this sample was 134.5. Alright, and then you can scroll down a little further and get the median. Alright, you notice this little arrow right here means there's more stuff below. And then MED is your median, so 132. Alright, now the other 2 values, the mode and the mid-range. The mode is the most frequent measurement that occurs. So if you look here, we got a 131 once, twice, 3 times, 4 times. Okay, so that's going to be our mode. But I'm going to show you another way to help with the mode, which is definitely going to help with our mid-range as well. But since it's just the most frequent measurement, we only have 14 values. It's kind of easy to identify the mode. But if it's harder, you can press the stat button and go down here to sort ascending. Okay, sort ascending, and then tell it which list. So our data is in list 1, so second L1. Hit enter, it says done, and now when I go into the stat editor, my list is sorted from largest to smallest. And now as I scroll down through here, I can see those 131s occur 4 times in a row, and so it's easiest to see them that way. Alright, now the mid-range, I need the largest and the smallest. So the smallest is one of these 2 120s. Alright, the largest is 150. So if I take the 150, add the 120 to it, I get 270, and then divide that by 2, I get 135. So our mid-range is 135. Okay, so you see all these values are relatively close to one another. I mean, they're not all exactly equal or anything, but they're all giving us a rough measure of the center of this data set, and they all have their different ways of doing it. Now notice that the mean is the only one of these that uses all the values in the data set. The mean averages up all the values, divides by how many values. The median is just, in this case because it's even, it's the average of the 7th and 8th numbers in this sorted data. If I go through here to the sorted data, there's my 7th number, 131. My 8th number is 133. I add those, divide by 2, I get the 132. Alright, so the mean is the only one that uses all the values. It's the one that we would like to use if we can, because it uses all the values. But if you have skewed data, if you're looking at a histogram and your data is skewed, you wouldn't want to use the mean. You'd want to go with the median. Alright, if you have a frequency distribution, instead of adding the numbers and divide by how many you have, you can't really do it that way. So if you have a frequency distribution, what you want to do is this list of directions. So you're going to find the class midpoints first. So if I'm looking at 40 to 44, alright, the class midpoint here is a 42. Okay, 45 to 49, the class midpoint is a 47. Alright, 50 to 54 is a 52. Alright, 55 to 59 is a 57 for the midpoint. 60 to 64, the midpoint is a 62. And remember, the midpoint is just the average of these two. So add them up, divide by 2. Alright, so I've done that. Now, multiply the class midpoints by the frequencies that are associated with those classes. So what I do here is 42 times 4. Okay, that's 168. Alright, 47 times 8. 376. Alright, and then 52 times 14, 728. 57 times 6, 342. 62 times 1 is 62. Okay, I got those done. Now add the values from step 2. So I'm going to add all these numbers up that I got from step 2. So that's 168 plus 376 plus 728 plus 342 plus 62. Alright, I get that. 1676. And then I'm going to divide that by the sum of the frequencies. Alright, the sum of the frequencies are these values. So 4, 8, 14, 6, and 1. So 33. Alright, so there's the values added from step 2. And then I'm going to take those values and divide by the values from, or the total of the frequencies. And that's going to give me my mean of the frequency distribution. Okay, 50.79 to 2 decimal places. Alright, and then it says compare that computed mean to the actual mean of 50.9 degrees. Relatively close, a little bit smaller. But again, we don't see what numbers, these 4 numbers in here that were in between 40 and 44, we don't know what they are. So we're using 42 to represent all 4 numbers. Okay, same here. It could have been 45, 45, 45, 45, 45, 45, 45, and a 49. Alright, but we're using 47 for all of them because we don't know. We don't have the original data set. We just have the frequency distribution. Alright, so that's why we're going to use this 4-step process to find it. If we don't actually have the data, if we have just a frequency distribution, we can still estimate the mean, but as we can see, it's not going to be exactly right. It'll be kind of close, but not exactly right. Alright, weighted means. So a weighted mean, let's say you have something similar to this. Let's say this is your grade breakdown for a class you're taking. So let's say on this first test you made, or your test average, you made an 83.2. Alright, and then let's say for your homework you had a 96.1 average. Your final exam you made a 79. Your project you made a 92, and your attendance grade was 100. Alright, if I want to compute the grade here, what I do is I take these weights as decimals and then multiply them by the actual value that you got for that grade. So 0.5 times 83.2 plus 0.1 times 96.1. Alright, 20% is 79, 15% 92, and 5% 100. Hit enter, adds it up. There's the grade for the course, 85.81. That's our weighted mean. And the weighted mean literally is it's how much do things weigh, and it's very similar to what we did right here with the frequencies. It's like this 42 had a weight of 4, this 47 had a weight of 48. But at the end, the only difference is when you do it this way, at the end you divide by this 33 because that's what these things add up to. Well, you do the same thing here. You're taking this and multiplying by this, adding this times this, just like we did before. But in the end, what do these add up to? 50, 60, 80, 95, 100, 100%. You're dividing by 1. So after you've multiplied these things together and added, you're done, because dividing by 1 is going to give you the same thing. So a weighted mean is very much like the mean of a frequency distribution. It's just your weights add to 1 when you're doing it this way. Alright, GPA. GPA is a weighted mean. It's just, it goes by quality points. So when you do this, a credit of 4, alright, a grade of 3, or sorry, a grade of B, which is 3 quality points. I'm going to put a 3, right here. Alright, this is a quality point of 2, another 3, and a 4. Okay, now, same thing. I'm going to multiply credit times grade. Alright, credit times quality points for the first thing. It's just like the frequency distribution thing. So it's 4 times 3 plus 3 times 2. Alright, 3 times 2 plus another 4 times 3 plus the 1 times 4. Alright, so this is how many total points that this person earned via these credits. And now we divide by the total number of credit hours. Alright, there are our weights for this one. So we're going to divide that 34 by, I'm going to put in parentheses, 4 plus 3 plus 4 plus 1. Alright, and then 2.83 is the GPA. Round into 2 decimal places for that semester. Okay, so a GPA is nothing but a weighted average, where the credit hours are acting as your weights this time, and your quality points are what you earned in that. Multiply those times these, and it's just like the frequency distribution thing all over again.